All right, so Google's new Willow chip, um, it's doing in minutes what would take the world's fastest supercomputer longer than the universe has existed.
It's really something else.
We're talking quantum leaps here.
Yeah.
Literally. Today, we're deep diving into this Google blog post about Willow and what it means for the future of computing.
Yeah. Should be fun.
Get ready to bend your brains a little.
Absolutely. And what's really fascinating is the blog post is written by Hartmut Neven,
Okay.
the founder and lead of Google Quantum AI.
Wow.
And what's really interesting is that he actually left the field of AI to focus specifically on quantum computing.
So he really believes in it.
So that says a lot about the potential he sees here.
Yeah, for sure. So let's break down what Willow actually is.
Yeah. So Willow is a new quantum chip developed by Google.
Okay.
And it's a big deal because it's achieved two major things. First, it's dramatically reduced errors, which have always been a huge hurdle in quantum computing.
Right.
And second, it's ridiculously fast. We're talking computational speeds that were pretty much unimaginable until now.
Okay, so you know how your computer starts to slow down when you open more and more tabs?
Oh, yeah, all the time.
Quantum computers used to have that problem,
Yeah.
but Willow seems to have solved it.
Yeah.
Let's talk about that error problem first. What exactly is going on there?
Well, quantum computers rely on these things called qubits, which are incredibly sensitive to their surroundings.
Oh,
Even the slightest disturbance can cause them to lose information.
really?
It's kind of like trying to write on a piece of paper in a hurricane.
I see.
So these disturbances lead to errors, and up until now, the more qubits you added to a system, the more errors you got.
So it was like a game of Jenga. The taller you build, the more unstable it becomes.
Exactly. But Willow has seemingly defined that logic.
Wow.
What Google found is that as they scaled Willow up to use more qubits, the error rate actually went down.
That's crazy.
They've achieved what's known as a below-threshold error rate, meaning the errors are now manageable and don't increase exponentially with the number of qubits.
So what does below threshold achievement actually mean for, someone who doesn't speak fluent quantum?
It's kind of like finally finding a way to make a photocopy that gets clearer the more copies you make.
Okay.
Which sounds kind of counterintuitive, but that's essentially what Willow is doing with quantum information.
Huh.
It's ensuring that the information stays intact even as it's processed and manipulated,
Right.
which is essential for any practical applications.
So that's pretty impressive. So Willow has tamed those unruly qubits.
Yeah?
But what about this insane speed we keep hearing about? The blog mentions a test where Willow did something in 5 minutes that would take a supercomputer 10 septillion years.
Right.
How is that even possible?
So they ran something called random circuit sampling, or RCS,
Okay.
which is a benchmark test specifically designed to be ridiculously difficult for classical computers. It's kind of like asking someone to solve a million Sudoku puzzles simultaneously.
Yeah.
It would take them a lifetime, but Willow just breezes through it.
And we're talking about a supercomputer here, not your average laptop.
Exactly. It's estimated that Frontier, the world's fastest supercomputer,
Wow.
would take 10 septillion years to complete the same RCS task that Willow did in under 5 minutes.
Oh my God.
To give you a sense of scale, 10 septillion years is longer than the entire age of the universe.
That's crazy. But it's moments like this that really drive home just how different quantum computing is. It's not just a faster version of what we have now. It's a whole new paradigm.
I totally agree.
Yeah.
And what's remarkable is that Willow's achievement isn't just about speed.
Oh.
It's also about the quality of the qubits and their ability to hold on to information for extended periods, which is called coherence time.
So it's not just a speed demon, it's also got a great memory. I'm looking at this table on the blog post,
Yeah.
and it shows that Willow's qubits can maintain that crucial excited state for nearly 100 microseconds, which is 5 times better than their previous generation of chips.
Yeah, that's incredible.
So the blog details a number of other key specifications for Willow, including its T1 times,
Right.
which is a measure of how long the qubits can hold information.
Yeah.
These T1 times are impressive and show significant improvement over Google's previous Sycamore processor.
Yeah.
They even talk about the state-of-the-art fabrication facility in Santa Barbara where Willow was created.
It's amazing.
Yeah. What was it like seeing this cutting-edge technology in action?
You know what struck me most was the level of precision and control they've achieved.
Yeah.
Building a quantum computer is like trying to orchestrate a ballet of atoms.
Uh-huh.
And Google has clearly mastered the choreography.
Wow.
It's fascinating to think that this incredible technology was born in a lab just a few hours north of us.
It's remarkable. But with all this talk about speed and benchmarks, it's easy to get lost in the technical details. What does all this actually mean for the average person? Where does Willow fit into the bigger picture of quantum computing?
Yeah, that's the million-dollar question, isn't it?
Yeah,
So we've established that Willow is an incredible feat of engineering.
for sure.
But the next hurdle is finding real-world problems where quantum computers can truly outshine classical ones. It's like having this amazing race car, but no racetrack to really push its limits.
So Google has built this incredible machine, but where do we actually race it?
Exactly. The key now is to find those applications where quantum computing can offer a real advantage. And Google seems pretty confident that the Willow generation of chips is the one that will crack this challenge. They're already encouraging researchers and developers to start exploring potential applications.
Cool.
And who knows, maybe one of our listeners will be the one to find that killer app.
I love that. Okay, so let's talk about those potential applications. What kind of world-changing stuff are we talking about here? Give us the good stuff.
Well, imagine personalized medicine,
Go ahead.
tailored to your unique DNA,
Wow.
allowing doctors to develop hyper-specific treatments with far fewer side effects.
That would be amazing.
Or picture super-efficient batteries that could power electric cars for thousands of miles on a single charge,
Oh, wow.
revolutionizing transportation and helping us combat climate change.
Okay, those are some seriously compelling use cases. But let's be honest, quantum computing still sounds pretty futuristic to a lot of people.
Yeah, I guess so.
Some might even be skeptical about its real-world impact. What would you say to those folks?
I'd say look at the history of technology.
Okay.
Every major breakthrough, from the internet to smartphones,
Right.
was once considered fringe science.
I see that.
People scoffed.
Mm-hmm.
They doubted.
Yeah.
And then boom, it changed the world.
Yeah, that's true.
Quantum computing is no different.
Okay.
We're still in the early stages, but the progress being made is undeniable.
For sure.
And the potential benefits are simply too vast to ignore.
It's like that old saying, those who say it cannot be done should not interrupt those doing it.
Exactly.
So what are the next steps? What needs to happen to bring quantum computing out of the lab and into our daily lives?
Well, there are several key challenges ahead.
Okay.
First, we need to continue improving the quality and stability of those finicky qubits.
Right.
Remember, these are incredibly delicate systems that require incredibly precise control.
Yeah.
We've made great strides, but there's always room for improvement.
Right. We need to keep those qubit divas happy. What else?
We also need to develop more sophisticated quantum algorithms.
Okay.
You know, that random circuit sampling benchmark we talked about?
Yeah.
It's great for proving quantum supremacy,
Right.
but it doesn't have any practical applications in itself.
Oh, I see.
We need to find more algorithms that can actually solve real-world problems
Interesting.
in areas like medicine, materials science, or finance.
So we need to teach these quantum computers how to do more than just speed through abstract puzzles.
Exactly. It's like having a Formula One car that can only drive in circles.
Yeah.
We need to find ways to unleash its full potential on real roads.
I like that analogy. It sounds like we need a whole new generation of quantum programmers who can speak this new language of computing.
Absolutely. And that's another challenge.
Okay.
Building a skilled workforce that can design, build, and operate these complex systems.
Right.
There's a huge need for quantum engineers, scientists, and developers right now.
So what does all this mean for our listeners? What can they do to prepare for this quantum future?
I think the most important thing is to stay informed.
Okay.
Follow the research,
Mm-hmm.
read articles like the one we're discussing today,
Right.
and don't be afraid to dive into the technical details.
Even if those details involve things like superposition and entanglement,
Yeah.
which honestly still make my head spin a little bit.
Even then, the more you understand about how quantum computing works,
Yeah.
the better equipped you'll be to navigate this exciting new landscape.
Okay.
And who knows, maybe you'll even be inspired to contribute to the field yourself.
This episode is certainly inspiring me. It's amazing to think that we're living through such a transformative moment in technological history.
It really is.
Yeah.
And while it's tempting to get caught up in the hype,
Yeah.
it's important to remember that quantum computing is a long game.
Right.
There will be setbacks and challenges along the way.
So no quantum-powered flying cars anytime soon.
Probably not, but the journey itself is just as fascinating as the destination.
True.
And with each breakthrough, like Willow, we're getting closer to a future where quantum computers can help us solve some of humanity's greatest challenges.
Okay, so we've established that Willow is a major leap forward for quantum computing. It's tackled the error problem, achieved incredible speed, and has the potential to revolutionize fields like medicine, energy, and AI.
Yeah, it's pretty incredible.
But there's one thing that keeps nagging at me. In the blog, Hartmut Nevin mentions leaving the AI field to focus on quantum computing.
Yeah,
He even calls his lab quantum AI.
that's right.
What's the connection there? How do these two seemingly disparate fields intersect?
That's where things get really interesting.
Okay, I'm listening.
You see, artificial intelligence as we know it today relies heavily on classical computers, which have their limitations.
Right.
They struggle with certain types of complex problems,
Yeah.
especially those involving massive amounts of data or intricate simulations.
So are you saying quantum computers could give AI a super boost?
That's exactly what many experts believe. Quantum computers have the potential to process information in ways that classical computers simply can't.
Interesting.
They can explore vast solution spaces simultaneously,
Oh, wow.
tackle optimization problems with incredible efficiency,
Okay.
and even simulate quantum systems that are far too complex for classical computers to handle.
Hold on, let me try to rephrase that in a way my non-physicist brain can understand.
Okay.
Are you saying quantum computers could be like giving AI a whole new set of superpowers?
That's a great analogy. It's like giving Superman X-ray vision or the Flash superhuman speed. Quantum computing could empower AI to do things we can barely even imagine right now.
Like what? Give me some examples.
Well, let's start with drug discovery. Imagine being able to simulate the interactions between molecules at a quantum level,
Okay.
allowing you to design drugs with pinpoint accuracy.
Wow.
This could lead to breakthroughs in treating diseases like cancer, Alzheimer's, and HIV.
So instead of relying on trial and error, we could use quantum computers to design drugs from the ground up,
Yeah.
knowing exactly how they'll interact with the body.
Precisely. And it goes beyond medicine.
Really?
Quantum computers could revolutionize material science,
Okay.
allowing us to design new materials with properties we've never seen before.
Like what?
Imagine super strong, lightweight materials for building spacecraft,
Wow.
or self-healing materials that could repair themselves.
So cool. Okay, I'm starting to see the potential here, but let's not forget about AI itself.
Right.
How could quantum computers change the way AI systems learn and evolve?
That's where things get really mind-blowing.
Okay, lay it on me.
Quantum computers could enable the development of entirely new types of AI algorithms.
Interesting.
Algorithms that can tackle problems that are currently intractable for classical AI. For example, quantum machine learning could lead to AI systems that are far more efficient at learning from data,
Okay.
recognizing patterns, and making predictions.
So we're not just talking about faster AI, we're talking about smarter, more capable AI.
Exactly. Quantum computing could be the key to unlocking the next level of artificial intelligence.
And what would that look like?
AI that can solve problems we haven't even thought of yet. AI that can help us understand the universe,
Wow.
design new forms of energy,
Okay.
and even tackle existential threats like climate change.
That's a pretty profound thought.
Yeah.
It seems like Willow is just the tip of the iceberg.
Yeah,
A glimpse into a future where quantum computing and AI merge to create something truly transformative.
it's exciting, isn't it? We're on the cusp of a technological revolution.
Yeah.
A revolution that could reshape our world in ways we can only begin to imagine.
Totally. And the best part is, it's just getting started. Well, my brain is officially fried. We've covered a lot of ground today. From quantum errors to supercomputers, from personalized medicine to the future of AI. What's the one key takeaway you want our listeners to walk away with?
I think the main takeaway is that this isn't just about geeky tech specs.
Right.
Quantum computing has the potential to touch every aspect of our lives,
Yeah,
from the way we treat diseases to the way we understand the universe.
I agree.
And while there are still challenges to overcome, the progress being made is remarkable.
So to our listeners out there, keep your eyes on this space because the quantum revolution is coming,
It is.
and it's going to be incredible.
It really is. And maybe, just maybe, one of you listening will be the one to make that next groundbreaking discovery.
Oh, I love that.
The one to unlock the true power of quantum computing. What world-changing applications do you think quantum computing will unlock?
That's a great question to ponder. Until next time, keep exploring, keep learning, and keep asking those big questions.